why do we need recommendations, right? So I love this quote from Steve Jobs, where he mentioned that, a lot of times people don't know what they want until you show it to them. And this actually explains, the real need of recommendations. So first thing you can say is like making aware your users what options are available, or it's like, trying to mimic brick and mortar shop with online marketplaces. Like, when you go to a shop, typically the shop owner knows your taste and he can recommend certain items to you. But when we, think of e-commerce, we can do it using recommendation systems, right? If we look at different use cases from different portals we use day to day, for example, let's say YouTube and Netflix. So typically they, recommend you for videos or some interesting content. And basically intent there would be, to increase watch time or attention of the user, right? So in case of LinkedIn, it will be something like this: show you relevant job postings, right? And what they expect is basically driving more applicants to their corporate clients, right? And let's say Amazon, if you're like browsing a particular item, then they will show you like some related items, right? The items frequently brought together or similar items like this, and which might lead to the additional sales, right? In the context of Delivery Hero, we want to show interesting dishes or vendors to get more conversions. Conversion meaning, let's say someone opened an app, and if it gets translated to the actual order, then we consider it as a conversion. And basically, if we serve the right recommendations, then we expect that there will be higher conversion rate, right? So in all, if you look at, all these problem statements, on the top they look slightly different, but at the core basically they are trying to address business need, where, basically in some sense they are trying to increase their revenue, right? Like if you, let's say, watch more videos on YouTube, obviously they will earn more on advertisements, or same is the case for Amazon. Like if you buy more from Amazon, they can have higher revenues and things like that, right? So in the context of Delivery Hero, we are recommending food, right? So it could be we are recommending vendors like restaurants, or we are recommending dishes, or we are recommending products like grocery products. And all these use cases are served using our recommendation APIs. So, okay, so now let's go to the next topic, which is I will explain you about some concepts from data science. And typically, like recommendation systems, we, that at the high level, you can say there are two approaches to it. One is content-based filtering, and the other is collaborative filtering. So let's have a look into, what it is about. So let's say user A orders something. Okay, we don't care, really what this is, but consider, let's say, some wrap. And then basically this dish has some sort of pre-tagged characteristics, like for example, what kind of cuisine is this, or what are the main ingredients for this dish, or what is the, spice level, is it too spicy or, not spicy, what is the price point for this specific dish, or, the dish name itself. There could be, n number of other pre-tagged characteristics for a particular item, right? So in this specific use case, we are considering this, but if you want to, think in abstract term, then you can say that, yeah, for an item, there are some certain features and they have certain values. And then Basically, this order is captured in this content based filtering, and then we basically say that okay, based on these characteristics, now I want to find some other dishes which are having similar characteristics. Okay, and then this system will return some other dish, and that will be served to the user. Okay, so this is really relying on this pre-tag characteristics. So a simplest implementation of it could be, let's say use some inverted index like Solar or Lucene or Elasticsearch, and you can already solve such use cases, right? I'm not saying that we exactly do the same in Delivery Hero. I will come back to what we do actually, but yeah. So this is about content-based filtering. Let me open the chat window as well, and okay. So there are no questions till now, and now let's move on to the next topic, which is collaborative filtering. So as we've seen in the content-based filtering, we needed sort of pre-tagged characteristics or attributes for the items, right? But what if we don't have them? Okay, so then the collaborative filtering comes to the rescue. For example, let's say here is some item and I don't know, like it's a burger, or I don't know the price of this item or whatever. But what I know is like, okay, this user A ordered this item and user B also ordered this item. Okay. So if we can collect this information from millions of users, like, okay, which users are ordering what orders, what dishes, we can get some sort of collective knowledge about it, right? Even if we don't know exact, let's say, ingredients of the dish, we can identify certain things like, okay, the this person, let's say, ordered some other dish which is, let's say, new entrant to the market, and this user liked that dish. Okay, and let's say whatever, she ordered again or something like that, which gives some sort of indirect indication that user has liked this dish, right? And then what we say is like this ordering event is captured in this collaborative filtering. So there is no as such direct pre-tagged characteristics, but what we get is sort of events, and then this system tries to infer some knowledge out of these events and try to identify, saying okay, looks like users. So hypothesis for this example is like this user like this dish A and this user like this dish B. Maybe the user A who liked dish A might also like dish B. Okay, so we can recommend this dish to this user as well. So if you really think of real life example, then it's simple to understand, and I'm trying to keep it simple for understanding in general. I mean, i I feel like if some of you are data scientists, they might curse me for oversimplifying the things, but just for understanding this level of simplification would be good enough, I would say. So typically, like here is the example just for two users, but you can think of it as you have 100,000 or millions of customers, and then you have 100,000 of dishes, and then we are getting orders. So there is like a many to many sort of mapping, and then this collaborative filtering will try to find out the overlaps and then identify, okay, which customers are similar or which dishes are similar, which vendors are similar, and based on that it can do such recommendations. So I would say these are the two high level approaches for recommendation systems. And then there is a sort of a hybrid approach which we use at Delivery Hero, and many other recommendation systems I guess should be using a similar approach, where we get a sort of mix of information. So some information it's sort of pre-tagged information. For example, vendor level details are available when vendors are onboarded to our platform, or product level details are available from their menu cards. Let's say price information, or what's the name for a dish, for example. But let's say ingredients it's something which is not always available. Some vendors will provide that information in the menu card, some vendors may not provide that information, right? Or the taste is very subjective, right? Uh, it's like spice level, for example. You can say it's not uniform across the globe, right? So it changes from one country to other. But there is some sort of implicit information, like for example, user ordering something is very important information, right? Or if we get a review for a particular vendor or particular dish, we can consider it also as a signal. If a user orders something, some vendor or some dish as a favorite, then that's also a good indication. Apart from that, we get indirect signals, like someone just casually browsing through some dishes. That's also a signal saying, you can say it's not as strong as orders, but still there is some level of interest. So we can consider it as a signal. Or sometimes some items are just or added to the cart, but they are not reaching till the checkout phase. But even in that case, we can say that there is certain user interest, and we can consider it as a signal. So the combination of, I would say, the pre-tagged information and some implied information can give you some sort of hybrid system, where you can combine content-based filtering and collaborative filtering, and build your models based on this. And then for models, there can be variety of options. For example, TF-IDF, which is like term frequency, and inverse document frequency, which is like basically, you can say every item is sort of associated with a set of keywords, and based on those keywords you're doing certain matchings, right? Or a similarity measure is I think a very broad term, I would say, but you can define similarity based on, again, the keywords, or you can even do the image based similarity and whatnot, right? Bayesian is a sort of probabilistic model, I would say. Nearest neighbor, SVD, singular value decomposition, neural network. So, you know, these are, I don't want to go into details. There is enough literature on the internet regarding, each of these individual models. And now we have, a number of libraries to train these models. Uh, so I don't want to really go into details of data science, but yeah, I mean, some of these are getting used at Delivery Hero as well. Let's move on to the next topic, which is touching based on the recommendations classification based on non-personalized versus personalized. Okay, so when I say non-personalized recommendation, it really means that it's not really specifically catered for that particular user. Like any user on the platform will see sort of same recommendations if other parameters are same. For example, two users ordering from a same location will get same list of vendors if you search for, okay, give me popular vendors around me, right? Because the popularity of vendors remains the same. So something like that. And yeah, so I feel like they are less complex in terms of computations. The reason is because we are not doing computation separately for each user, right? So yeah, it's less computations. And here are some examples. So for example, top rated restaurants. So this is based on the feedback we got in terms of reviews or in terms of bookmarks, or maybe we can add even the ordering information, and this will give us top rated restaurants within that particular locality, right? So here is a other example where user was searching for Kellogg's some cornflakes, and then maybe we can suggest some similar products, maybe some other variant of cornflakes with different flavors, or some other items which could be useful for breakfast. And then comes the personalized recommendation, which is, I would say, comparatively more expensive in terms of computation, because each user can have different recommendations. And then, yeah. So here are some examples. For example, we have order again, where we say that based on your past orders or based on the dishes you have bookmarked, we can show these particular dishes or vendors. And then this is recommended for you, which is sort of the hybrid approach which I explained, like the combination of content based and collaborative filtering is actually getting used in this, which means basically we are collecting signals about orders, about the actual content, like the keyword tags and so on. And yeah, so this is an example for personalized recommendations. Okay, so now let's move on to the data pipeline part. So in data pipeline, the name implementation, if you go to any backend developer and ask, I want to build such a system where basically, let's say, yeah, here is the content, and then I want to get top rated restaurants, right? How will you solve that use case? Okay, so they will say, yeah, it's simple. Like, yeah, we already have, ratings table in our database. We can fire an SQL query and get this done. Right? Looks simple. Agreed. But the problem is this will not scale. Why? Because if you do sort of, select from ratings, and if you're selecting all restaurants in that particular locality, let's say, and doing certain group by and where conditions, this query is sort of, if you're hitting, let's say, 100,000 requests every minute, then this is not going to scale. So what's the alternative is basically having pre-computed recommendations, and that is all data engineering is all about, I would say. So right now, we can say, okay, the first implementation could be a batch implementation, and that's where we even at Delivery Hero started with. Like what we do is basically we have a centralized data lake where all teams push their data to the data lake, and all consumers of data can take data from data lake and build their own data pipelines. So for recommendation systems, we can say starting point is data lake, where we get all this, let's say, whatever user reviews or orders and whatnot, uh, or even click streams if you want. And what we do is basically we fire this periodic queries for pre-computing, and then these results of these queries are stored. So based on the use case, we decide whether Basically, we fire the periodic queries. So queries, I think in the nature will be similar to this, but instead of querying it for a specific user or specific location, they are like computed at more generic level. Like we basically try to score the restaurants and store their lat longs, and then maybe we can index based on lat long, and then then you can say okay, order by score, and search within this particular radius for lat long. So that is done in the API side. But when you do the periodic queries, basically we try to do it for the entire country, let's say, or all customer IDs for that particular country, right? And then these results are stored either in database or in memory based on the data size. For example, product catalog, it could be easy to store this information in memory. But if you are doing it for customers, then we have many customers, then yeah, maybe it won't fit in memory. In that case, we can think of going to a database. Then there will be slightly higher latency, but at the cost of we get more scale out. So it depends on what is your priority and what is your business use case. And then we have streaming implementation. So when I say we have, meaning like conceptually, you can have a streaming implementation of the same pipeline. And this is, I would say, on the lines of what David mentioned in his question about online learning. So these basically pipelines are sort of online, where they try to process data on the flow. So on the flow, meaning data lake will have, like, instead of having the dump of data, let's say all the orders till yesterday, it will have a stream of data where it says that okay, once a new order is triggered, it will be part of as a new event in the event stream. And then you can subscribe to that stream and get data in your data pipeline. So in your data pipeline, what you do basically is consume that particular stream, and then you try to update the pre-computed results. So earlier approach was doing sort of fresh computations every day to update the scores. But this will be like, okay, I already have some scores and I just want to calculate delta. Okay, and that's I would say a streaming approach. But we haven't yet reached this state of having streaming updates for our recommendation pipeline. Yes, there are some use cases which are using streaming for other use cases in Delivery Hero, but for recommendation use case, right now we are using the earlier approach, as I said, the batch implementation. And do you use cloud? The answer is yes. So you can look at actually the stack share page for Delivery Hero, and you will get to know that basically mainly we are using Google Cloud as well as AWS, depending on which team. But for recommendation use case, we are using Google Cloud. But actually what I'm trying to explain in the diagram is irrespective of whether you use cloud or not. Okay, so even if you see this cloud shape in the diagram, it need not necessarily be in the public cloud. You can have your own on-premise cluster, and then work with that cluster, like as already mentioned in my intro. Like earlier, I was working on the Hadoop ecosystem, and with Hadoop, you can already build, your mini sort of in-house cluster to do build certain data pipelines like this. So even if you don't have a, let's say, subscription for a public cloud, you can still do it. Or even if you want to explore something as your hobby project, you can still do it. Yeah, so we already saw batch and streaming. Yeah, then about combining multiple strategies. Okay, I think this picture is not clearly visible, but you can see there are some horizontal lanes, and which are like horizontal scrollable components, and we call them swim lanes. But what they really do is like each of these things is different recommendation strategies, and then it could be order again, panda pics recommended for you, whatever. We try to measure conversion rates for each of these swim lanes, or widgets separately, and then we try to optimize based on the conversion rate. So here are here is the snippet from our Google Analytics. So we use Google Analytics for tracking the clicks and conversions. So basically, unfortunately, I cannot disclose the actual conversion rates, but I would say that basically this control, original, variant, these are like sort of for every strategy we have like some sort of experiments running, and then there will be like the original, which is like a baseline, and then control versus variant, which is sort of A/B test. And then we try to see whether the new experiment is having the uplift in conversion. And one more thing is like sometimes conversion is not the only criteria, because let's say if one of them has the higher conversion, but if it is stealing traffic from some other strategy, then at the end, overall as a business, you might get the same let's say GMV, right? Basically the total sales. So um, it really depends on what KPIs you are trying to optimize, and based on that, you can decide on what strategies to show on top, and you can decide reordering, or you can do tuning of your strategies. For example, let's say if you're doing popular restaurants, you can say like whether I want to measure popularity for 6 months or 2 months, or should I show only within 2 kilometers, or should I show like 4 kilometers. So these are the trade-offs or tuning parameters, or for content-based filtering, collaborative filtering. Every strategy will have some sort of parameters, and parameters need to be tuned. And this can be done either by A/B test manually, or you can build a system, which we are already sort of in progress, work in progress, where we are trying to build a automated system based on MAB, which will do these things. Yeah, exactly. So David asked the same question. MAB, multi-armed bandits. It's sort of on our roadmap. We are sort of it's a work in progress for us.